Good afternoon. We have first questions. Which of the strategies of reducing error discussed you are already using? The strategies of reducing error discussed I've been already using is the use of the enter K. My most common errors in financial models are silly formula mistakes. For example, I have an assignment on statistics, so I'll try to entering a formula of sum equals SU instead of SUM. So we'll give the error of name when I use sum to add the cells together. Excel assumes that the references are numbers. Whenever Excel doesn't find what it expects, it will return an error message. Excel alerts those errors by putting different symbols in the cell. Similarly, in the null happens if the user enters an incorrect range. Second question, we have which of the strategies of reducing error discussed sounded new but will be easy for you to adapt? Expand your answer. The strategies of reducing error discussed sounded new but will be easy to adapt is conduct a scenario analysis. Scenario analysis can help you to make better decisions or to plan your business strategy by challenging your assumptions about the future. Exploring a range of alternative scenarios allow you to identify potential risks and plan how you will counteract or mitigate their impact. Also, allows you to change or substitute input values for multiple cells. Therefore, you can view the results of different input values or different scenarios at the same time, but it only identifies how far a variable needs to change. It does not look at the probability of such a change. It provides information on the basis of which decisions can be made, but it does not point to the correct decision directly. Third questions, which of the strategies of reducing error discussed you are in doubt of following? Explain. The strategies of reducing error discussed I doubt is document methodology with a flowchart. The flowchart is quite costly to produce and difficult to use and manage, for the reason that flowcharts are not meant for man-to-computer communication. Sometimes the complex logic of the program logic is quite complicated to draw out by using different defined shapes. In that case, the flowchart becomes complex and clumsy, but it can sometimes help to have a diagrammatic flowchart that explains the way that the numbers have been calculated in your model. Fourth questions, we have which of the common pitfalls discussed you are already avoiding, and cite the example situations. The common pitfalls discussed you are already avoiding is the formulas are unnecessarily long and complicated. Keeping formulas as simple, clear, and straightforward as possible is always good practice. But remember that the model is not only for you to use, it should be a tool that anyone in your team can pick up and understand with minimal explanation from you. For example, complex formula using the order of operations. Here we want to calculate the cost of sales tax for a catering invoice. To do this, we'll write out our formula as in the cell D4. So this formula will add the prices of our items together and then multiply the value by the tax rate to calculate the cost of sales tax. So it is difficult to solve this problem because the complicated of the formula. So fifth questions, we have which of the common pitfalls discussed sounded new but will be easy for you to avoid? Expand your answer. The common pitfall discussed sounded new but will be easy to avoid is you have circular references. Circular references are the result of a formula that somehow links back to itself, contrary to what some modelers claim. You should not allow a circular reference in your model. If you're building a model, the best way to avoid circular references is to simply undo what you just did as soon as the circular reference warning appears. If you've inherited a file that contains circular references, you can end up spending a lot of time trying to get them sorted out. Last questions we have, which of the common pitfalls discussed will be hard for you to avoid? Explain. The common pitfall discussed, it will be hard to avoid, is your model is full of spaghetti links. A link that links to a link, which then in turn links to another link, and so on throughout the model is called a spaghetti link. A spaghetti link can be confusing and difficult to follow, and they are not good modeling practice. Wherever possible, you are always much better of linking directly to the source.